Ever wondered how data travels over the internet? It's no magic, but the work of networking protocols and systems working tirelessly behind the scenes. You see, the internet is a complex web of interconnected devices, each sending and receiving data to make our digital lives possible. And at the heart of this data transfer process, the transport layer protocols. These unsung heroes of our networks ensure that information gets from point A to point B, intact and in order. In this video, we're going to explore some key concepts of the transport layer: ports and sockets, TCP versus UDP, and flow control, error checking, and windowing. These might sound like a mouthful now, but by the end of this journey, you'll be conversant with the inner workings of the digital highways that make the internet possible. Join us as we delve into these fascinating concepts that make our online interactions possible. Imagine the internet as a bustling city. In this city, ports and sockets act as the addresses and mailboxes. To understand this, let's break it down. Port numbers are like apartment numbers in a large building. They help identify specific processes or services on a computer, much like how an apartment number points to a specific residence. There are over 65,000 ports available for use, just as there are many apartments in a city. Sockets, on the other hand, are like the mailboxes associated with these apartments. They're the endpoints where data can be sent or received. When a connection is established, a socket is created. This socket is like a mailbox that both sends and receives data, just like you can both send out and receive mail from your mailbox. So, in essence, when data is sent over the internet, it travels from one socket to another, guided by the port numbers. So, ports and sockets are the unsung heroes, ensuring that the right data reaches the right place. Now think about how data travels in the city. There are two main routes, TCP and UDP. These are like the highways and byways of data transfer, each with its own unique characteristics and ideal uses. TCP, or Transmission Control Protocol, is like a reliable, diligent delivery driver. It ensures every bit of data reaches its destination in the right order, with confirmation receipts at every step. It's ideal for when accuracy is crucial, like sending an email or loading a web page. On the other hand, UDP, or User Datagram Protocol, is the speedy courier. It sends data fast, without waiting for confirmation receipts. While it may not guarantee every piece of data will arrive in order, it's perfect for time-sensitive tasks, where speed trumps precision, such as streaming videos or playing online games. So you see, both TCP and UDP have their own strengths and roles in the intricate dance of data transfer. Whether it's TCP's reliability or UDP's speed, both play their parts in the grand scheme of data transfer. But how do we ensure smooth traffic and prevent accidents in our data city? That's where flow control, error checking, and windowing come into play. Imagine data transmission as a city's traffic system. Flow control acts like the traffic lights regulating the movement to avoid congestion. In the context of data transmission, it ensures that the sender doesn't overwhelm the receiver with more data than it can handle. It's a delicate balancing act to maintain optimal data flow. Now, what happens when an error occurs? That's where error checking steps in. Think of it as our traffic police, spotting and correcting mistakes. In data transmission, error checking identifies and corrects errors that may occur during the transmission process. It ensures that the data received is the same as the data sent, maintaining the integrity of the information. Lastly, we have windowing. It's like the city's traffic management center, overseeing the entire process. In data transmission, windowing manages the amount of data sent before receiving an acknowledgement from the receiver. It's a way to keep track of which packets have been acknowledged, which need to be resent, and when to send the next set of packets. Together, these three mechanisms work to ensure that data transmission is efficient, reliable, and error-free. Like a well-oiled traffic system, they manage the flow, spot and correct errors, and oversee the entire process. These mechanisms keep the data city flowing smoothly, preventing congestion and ensuring every bit of data arrives intact. So that's the journey of data over the internet in a nutshell. We've explored the integral role of ports and sockets, acting as the gateways for data to enter and exit. We've delved into TCP and UDP, two protocols defining how data is sent and received. And finally, we've tackled flow control, error checking, and windowing, the mechanisms ensuring seamless and accurate data transfer. Each part plays a crucial role in our daily digital interactions. Next time you browse the web, remember the complex processes working in harmony to make it all possible.